So my name is Marius Holmsen. I'm the Prisma Cloud sales representative, and I'm covering currently Norway, Finland, and Baltics. And today I will talk about Prisma Cloud and what we do from a cloud-native security solution here at Palo Alto Networks. So what we see today is that most customers have a cloud strategy, and what we see is that strategy usually comes into two flavors. First, they tended to move their what we call their more traditional applications to the cloud, but we quickly realized that that doesn't give us all the really good benefits with the cloud. And that's when we see that more and more customers now start to deploy what we call the cloud native applications. That means that they move away from the more traditional virtual machines into container-based applications and also like serverless functions. And there are some security challenges now with the new way that we deploy applications, because traditionally we have been deploying security policies into more like like firewalls and more traditional kind of security solutions. But the new applications gives us some new challenges, because some of the complexities in identifying which microservices communicates to what other microservices means that we need a new way of deploying security policies specifically for the cloud. And we also see that this is also applicable for what we call the hybrid cloud or the private cloud. A lot of customers want to use these benefits now also in their own private data centers. And that's why we see that there's a huge upspring these days with like Kubernetes and other container-based solutions in order to gain these same benefits in their own private data center. So what we kind of realized in Palo Alto with Prisma Cloud is that the heart of the data center is actually the application itself, right? Because the most valuable asset we have are our data, and the ones consuming the data and presenting the data is the application. So if you think about the application as the heart or the center of the data center, it means that we need to create the security solution around the application itself. And as I previously mentioned, right, we do see that the way that we deploy applications have recently changed into this new, more dynamic, agile, cloud-based applications. And this means that we need like a new security tool to make sure that we can, scale up, scale down, be agile, and actually give visibility and insight into these applications. So when we think about how we deploy these modern applications, we also see that there are some challenges and risks in the way they are deployed. So if you think about the application itself and the way it is deployed, we kind of boil it down or kind of break it down into three different phases, right? The first thing we do typically is that we code and build the application, and then we kind of package it and deploy it. And at the end, we also obviously have what we call the kind of runtime. So after we have deployed the application, it runs in our private data center in the private cloud, or it might run in any public cloud. And the more security challenges we can address in the earlier phase means that we have less issues to deal with in the run phase. So if we are able to actually avoid some security challenges before we deploy the application, it means that we then avoid these kind of security challenges to actually become an issue for us in the run phase. So if you think about the code phase, right, and one of the main benefits with the public cloud is that the way we used to build our infrastructure in the private data center was that we used to have like a networking team, a security team, virtualization team, and a server team, and perhaps a storage team. These days, we see that a lot of customers move towards what we call infrastructure as a code. So this means that they use then a template to deploy that full infrastructure. And this could be in the forms of like, Terraform, ARM, Bicep, or even CloudFormation for AWS. And it's as we used to have multiple teams, validating and make sure that we didn't have issues in the actual infrastructure before we deployed. It's more challenging now when you can deploy infrastructure as a code, because it means that there's less people perhaps that actually kind of validates that the security policies are met before the infrastructure is deployed. So what we have been trying to do in the code and build phase is to move left in that whole deployment phase and be able to kind of, first of all, validate that what we deploy in the infrastructure meets our security policies. And at the same time, we are trying to bridge this between the cloud team, the developers, and the security team. So this means that me as a security administrator have the possibility to make sure that there is no insecure configurations being deployed, there is no misconfigurations, there is no vulnerabilities, there's no security issues being deployed in the cloud before it actually is deployed. And at the same time, the developer doesn't have to change the way he normally works, because he will be also notified in his development environment that this policy violates the corporate policy or the best practices for the cloud, which means that the developer can easily change this code in his platform without having to feel that security is holding him down or is slowing his process. At the same time, we also have the ability to make sure that there's no vulnerable code. As I mentioned, there's no secrets exposed in that code, or that there's no security issues in the kind of version control system you use. And all of this is what we tend to refer to as shift left, because it means that we can then address a lot of these security challenges even before the application is deployed. And if you think about the recent vulnerability with like Log4j, we then would have the possibility to ensure that we don't introduce these vulnerabilities even in the code and build phase of the application, right? And the next phase is typically then when you take this code and you can package this code before it gets deployed. And this is where we then could have malicious images. We could have image poisoning. We do know that in this case we are able to kind of detect if we have any of those security issues before we actually place that application to runtime. And in this case, we could also go into the actual developer CI/CD pipeline. So the way developers basically then have the code, deploy the images, and then place those images into the actual runtime, we will be able to kind of notify the developer itself that you should not use these images because here we have clear security vulnerabilities, or there is malicious code in here. So this means that we then are able to also notify the developer in his own pipeline that these kind of security challenges need to be addressed before we place the application in runtime. So when we then finally have been able to kind of verify the code, verify the images, the builds, and then place it into runtime, we also slightly need to think about how we do runtime protection. Because one thing that is different with the new application framework used in the cloud is that they would like to continually change and develop this without having to be interfered by the security team. So in the old days, it used to be that the application guys had to go to the infrastructure guys and the kind of security team and make sure that they have the kind of correct firewall openings, which the developers and the application guys felt that kind of slowed down their process. So the way we do this now with Prisma Cloud is slightly different than what we are used to with kind of security policies. So this means that instead of the developers having to specify what they kind of require from the infrastructure, Prisma Cloud is able to detect how an application behaves and create what we call a role model, or like a container-based model. And this is applicable also to hosts like VMs, and also to the kind of serverless functions. So this means that instead of the application owners or the application developers having to communicate to the kind of security team, the security team can see how the application behaves, and the application and Prisma Cloud itself creates this role model saying that these are the processes that we see are on these instances. These are the file accesses, these are the network communications that we see, and this is how we will lock down this application, because now we have learned how the application behaves. So we call this application zero trust, because it means that we don't have to look for specific misbehaviors. We basically look for everything that violates, that breaks the model that we have learned on how the application should behave. And it also means that the only thing kind of required from a security team is to create like a predefined policy saying that what will I do if something violates this model? Which predefined action should we take if something suddenly breaks the predefined role model that we have learned? And the three actions we can take from a security team is that we could either say that I would like to be alerted if for some reason something suddenly changes with how my application behaves. The other thing is that we could automatically kill that new process, that new behavior that breaks the kind of behavior based model. And we also have the possibility to kind of kill the container itself. And the really good thing about the way this new application framework is built is that specifically for containers, there is a container orchestrator. So if we kill a misbehaving container, the orchestration will then create a new one, which means that we don't really break the application itself. We only break that microservices part of the application that is misbehaving, and then it will automatically be deployed a new instance without that security breach or without that security violation. So this means that instead of having pinpointed solution for every step of this journey, what we're trying to achieve with Prisma Cloud is to have like one common platform that secures the whole application lifecycle, from even before it is built, from when you actually take that code into your images and when you deploy that into the cloud, and then secure it the whole journey in the cloud. So this means that the security team will have the visibility, insight into all of these processes, and at the same time we will not interfere with how the developers normally develops, operates, and manage their kind of code and their applications. So there's really some, if you think about the typical challenges with the different cloud solutions, right? They come with some potential problems or some issues that we have seen from a security point of view, right? A lot of solutions focus on what we call runtime. So this means that you only see how it behaves when it's actually running. And these typically tend to that you might have hundreds or thousands of alerts in your kind of runtime environment. What we're trying to do with the ability to go into from the kind of code and the build phase is to be able to kind of detect these and solve these security issues before you actually deploy the application. So this means that you save yourself a lot of after work or basically a lot of tasks to do after it has been deployed, because you're able to basically address these security issues before the application is deployed. And this also means that we then only give you visibility, but we also are able to actively prevent something happening, right? So if you think about visibility, which is really good because you can then see if there is some misbehavior. But with the solution I mentioned previously, where we can basically learn how the application behaves, create that zero trust application framework, we have the ability to create predefined policies saying that if something breaks my behavioral-based learning model, I will take one of these predefined actions. And this means that we don't give you like a 12 or 24 hours scan to kind of show you what's going on, but you can actually prevent something happening in real time, because we will then detect that here there is a deviation from how we have learned that the application should behave. One other thing I would just like to kind of mention as well, right, is that if you think about the kind of process I mentioned earlier, where we basically have the possibility to be in there from the code phase to the build phase to the deploy phase, it means that if you typically address this with kind of normal tools, you would have single tools for every one of those phases. But if you can have like one single platform, which is what we're trying to achieve with Prisma Cloud, having that single platform for that whole journey, it means that you can have one tool that will give you that visibility for all of those phases. So just to kind of quickly summarize on this one, right? It means that instead of just looking at the actual runtime, we could then give you like a comprehensive security all the way from the code itself to actually running in the cloud, or it could be your own private cloud, or it could be any private cloud. And not just visibility, but also the ability to do prevention means that you will not only detect, a security breach, but you have the ability to actually prevent it, right, in real time without any human touch, because we have created this zero trust application framework where we know how the application should behave, and we will do predefined action based on any kind of deviation from that, right? And with not doing like scans every now and then, but with the possibility to have real-time visibility, it means that we will show you at any time, any second, how is your application behaving? Do you see any kind of deviation? And we will then automatically detect them, in real time. So just to kind of quickly summarize, right? It means that we are trying to provide like a full-fledged platform for the kind of cloud journey that starts even before you have deployed anything. It starts when you actually do your kind of coding. We have the prevention first strategy, which means that we will not only detect any security issues, but we will be able to also prevent them from happening, right? And with the kind of continuous real-time visibility, it means that you will get an overview of your infrastructure, your applications, your kind of cloud assets at any time, any second, and see how they are actually behaving. So just to kind of summarize once more, right? If we started with the code to the cloud, where you deploy your infrastructure, you defined that you will create a VPC, you will create some applications. We have the ability to look into the actual developer platform, and we are able to kind of scan through the code, make sure there is no misconfigurations, there's no vulnerabilities introduced. It means that you can actually stop them before they are deployed. And with the prevention first through all of these different phases, it means that we are absolutely sure that if something happens, if something are kind of violated, we will stop those things from happening instead of only showing you what's happened afterwards, right? And with the real-time visibility, we can also ensure that you can get a full compliance report, a full security policy monitoring report across all of your environment in real time. See that, do I have any compliance kind of violations, I can create my own security policy, make sure that that policy is being adhered to across all of my assets, across all of my different clouds. And if you think about the from a scaling perspective, right? Today we can protect more than 8 billion assets. So that this means that 8 billion assets in the kind of public cloud or in customers' private cloud, and we are able to do to also process more than 700 billion weekly cloud events. So we will gather all of the configuration, all of the audit logs, all of the flow logs, and give full visibility for all of the kind of assets that every customer have, and give them a full report to basically show if all of their assets meets the kind of current security policy. So let me just quickly skip this one, right? So if you think about the cloud journey I just mentioned, right, it means that when you create your code, it's not like in, I would almost say like the old days, but it's not like that you build your code from scratch. You use third-party libraries and it's sometimes difficult to get a full visibility of your full, supply chain. Do I introduce any vulnerabilities or any misconfigurations in the kind of third-party libraries I use? So this is from the code phase. We are able to basically scan, validate, make sure that everything you use, even from like third parties, doesn't violate or break your kind of security policy, right? And then we then also kind of validate that anything you deploy in the cloud from the infrastructure point of view, when you might create your VPCs, you might also create your security groups and your policy. And if you do this with like a single click of a button with like the Terraforms or the cloud formations, we are absolutely absolutely sure that none of the configurations that you use violates your security policy. And the good thing that I also mentioned previously, right, is that this is not only for the developer itself, but for the kind of security administrator also have the possibility to look into those templates. And if the security administrator sees some security violations or something that he would like to address, the security administrator could then create a pull request into the kind of developer's repo and ask the developer to change a configuration in that infrastructure as a code template. So this means that one of the challenges we have seen previously, right, is that there has been like a disconnect between the developers and the kind of security administrators, right? And there's also been used to being that the kind of developers deployed the infrastructure in the cloud, the security guys realized something was misconfigured, and then the security guy had to kind of communicate to the actual developer, asking him or her to kind of change that template. We have automated that process, right? So it means that the kind of developer could be anywhere in the world on his or her IDE, and the kind of security guy would also see the same templates, the same Terraforms, CloudFormation, or ARM, Bicep, and then they could actively request a change by creating a pull request, and then the kind of developer will see that they would like to change these configurations because it doesn't meet the kind of security policy. It means that the kind of security is not showstopper or a hassle or something that the kind of developers would like to avoid, but it's an automated, integrated process. And at the same time, if the kind of developer is creating a new template and it kind of breaks one of the predefined policies, and we have like 800 policies out of the box, but you can also create your own corporate policies on top of that. the actual developer will be informed as he types that this configuration now violates a policy, and he can easily right-click and say, fix this to meet my security policy. So this means that we have taken away that friction between the developers and the security team. So yeah, let me just quickly skip that due to time. So just to give you an overview of the Prisma Cloud architecture, right? If you think about, like I mentioned earlier, we see most customers today move away from the more legacy applications into new application frameworks, and these applications, tend to be based on a microservices architecture. So this means that instead of having like one huge application, you now have multiple microservices that communicate to each other through APIs. And one of the kind of challenges we see with the traditional firewall and how we create policies in the firewall is that it's very difficult for us to identify which microservices is communicating out, because they're all hidden by the same IP address of the container host. So what we have been able to do here is to move that security visibility all the way into the applications and basically show you who is communicating to whom, which APIs are they using, which APIs should be allowed between these microservices. At the same time, you might have your infrastructure or assets in the different public clouds, or you might have them in your own on-prem environment. So you can basically decide, if I would like to kind of protect my environment with a prevention first method by using an agent, or if I am happy by only have the visibility into my, if I meet my compliance and if I would just have visibility into all vulnerabilities and my potential also compliance issues, we can do that agentless. So we will also through APIs gather all of the kind of configurations, the audit logs, the flow logs, the DNS logs, and give you a full visibility of all of your assets that you have in the public cloud. And by gathering all this data and also integrate into the kind of DevOps toolset, the different IDEs you might use, we can give you then a full security journey that basically secures everything from when you start doing the cloud to after you have deployed your assets in the cloud. Make sure that all of your cloud assets meets your security policy and also meets all of the best practices for the cloud. And then obviously what I mentioned with the cloud workload protection, where we then on an agent-based or agentless-based can basically create this zero trust application framework to make sure that all of your application behaves the way they were supposed to behave. And if we see some abnormalities or some changes in behavior, we then have the ability to do predefined actions and make sure that we can then kill that new deviation, that new process that suddenly made your application started to kind of behave differently, or we could actually kill that container itself. And one of the challenges that we also see with the public cloud is that the different clouds have different ways to create network-based policies, right? So if you think about, if you have something on-prem, maybe you have ACI or NSX, then you have one set of policies for your on-prem environment. And then you might have multiple cloud accounts or multiple cloud providers, which means that you end up with different security groups and different policies for each of and every cloud and network that you have. So one thing we have been trying to do is what we call infrastructure agnostic policies, right? What if I could create a policy that doesn't tie itself to one specific cloud or one specific infrastructure? What if I could create a policy saying that all my workloads that meets these criteria will get this policy? So I could say that all of my workloads that matches production application A front end are only allowed to talk to production application A backend. It doesn't specify anything if it's on-prem or if it's in AWS or it's in Alibaba, but it basically says that if my assets meets this criteria, it's able to kind of communicate to these assets because they have these matching criteria. It means that I then could have a fully, infrastructure agnostic policy. And that's what we've been trying to do with the kind of micro-segmentation we have called cloud network security. And we also realized that most customers, right, even though we have a platform that takes you to the full cloud journey, most customers use other means to kind of monitor their kind of security environment. And that's why we, from Prisma Cloud, we will give you a graphical user interface where you can see all of your kind of workloads, all of your assets in the cloud and the kind of security policy, and if they meet or doesn't meet that security policy. But we can also inform through any third-party integration to make sure that if there is something that kind of violates this policy, or if we have any alarms, that we also then can inform through the multiple integrations that we have.